Good morning, class. I hope you're all doing well. You're welcome to the second theory class. It's been a few weeks after the midterm exam, and I know a lot of you are complaining about the questions, and some are saying it didn't go well, some are saying it went well. One thing that I want to advise you about is how you read. I would advise you to practice more, because when it comes to circuit and circuit analysis, some of the time it can be a little bit dicey. So you have to study hard and practice frequently, and that will really help you when you meet questions like these. So question number one, it's very pretty simple. It wants us to find the V naught, right? It wants us to find V naught using nodal analysis. So it's very simple, right? When I say it's very simple, I mean it's simple, right? And the examiner has done some work for you, identifying the supernode for you. So if this is the supernode, then we are going to solve the question straight away. And in this question, we are going to apply the Kirchhoff's current law, which says that the algebraic sum of currents entering and leaving a node sum up to 0, right? So if you have this in mind, we have a supernode, right? So two nodes with a voltage source in between, right? So we are going to work around that supernode. Now let's identify all the currents leaving that node and all the currents entering that node, right? So we see the 8 milliamp currents, we see it entering node V1, we see the 2 milliamp currents leaving node V1, and there will be a current leaving here, there will be a current leaving here, a current leaving here, leaving this node, a current leaving here, right? So that's what we have in here. So we are going to solve it as such. Now, if we take node V1, according to Kirchhoff's current law, right? According to Ohm's law, we have the voltage out of the resistance, and that will give us the current. So we have V1 out of 3 kilo ohms, right? Plus, we have another current here, which is V1 plus 12 out of 6 kilo ohm. That will give us another current. So V1 plus 12 out of 6 kilo ohms. There's also another current leaving here, right? And that current is going to be V1 plus 12 minus V naught. The reason why it's minus is that we are moving in the direction of the current. So plus V1 plus 12 minus V naught out of 2 kilo ohms, right? Now when we come in, we have another current leaving here, which is a 2 milliamps. So plus 2 milliamps. And there's one current which is entering, right? Because it's entering, we have negative 8 milliamps, and that will give us 0. Let's do the simplification and get an equation out of it. We multiply 2 by 6k, we're going to get 2v1 plus v1 plus 12, v1 plus 12 plus 3v1 plus 36 minus 3v naught. And this is going to give us, so the kilo will cancel the milli, meaning that we are going to get 12 here minus 48, giving us 0, right? When we simplify this, you can see that this will give us 6v1, right? We have 3v naught, so 6v1 minus 3v naught, and 12 plus 36 gives us 48. We have negative 40, it cancels out, so we are going to get 12, 36 will cancel out, 6 will cancel out. So we're going to get minus 12 at the end. So this is the equation. This is a simple equation we arrive at, which is 6v1 minus 3v0 equal to minus 12. Very, very simple, right? Because our board is small, we are going to clean this, maintain this equation, and move on to the next node. Okay, so this is our equation 1, 6v1 minus 3v0 equal to negative 12. Take it as equation 1. Okay, so let's take the second node fast forward. We are taking v0, right, as our second node. So what we are going to do is that we see the current entering and the current leaving. We have this current entering, we have these currents leaving, right? So 2 milli will be equal to, if this current is leaving, we are going to have v0 minus v1 minus 12 out of 2 kilo ohms plus this current is also leaving v0 out of 1 kilo, right? So we multiply 2 by 2 kilo ohms, and we're going to get 4 v0 minus v1 minus 12 plus 2v0, and this is going to give us 3v0 minus v1 equal to 16, right? And we get this as equation 2. Now we are almost done with the question. What we are supposed to do is that we solve it simultaneously, right? So we have equation 1 here, equation 2 here. So what we are going to do is that we are going to add equation 1 to equation 2, making it very simple. So we add equation 1 to equation 2, we are going to eliminate v0, right? We are going to eliminate v0. So we are going to get 5v1 equal to 4, meaning that v1 will be equal to 0.8. So we have v1 to be 0.8. So we take any of the equations and we insert v1, right? We substitute v1 with 0.8, and that is going to give us the value of v0. So it will be 3v0 equal to 60 plus 0.8, and that is going to give us v0 equals 16.8 out of 3, giving us 5.6 volts. So it was very simple. If you follow the rules, you are going to arrive at this simple answer. Any questions?